Hello everyone, welcome to MindSpan Education. Last video we looked at the total probability theorem and the total expectation theorem in terms of the probability density function notation. We have already seen the various version of this probability and the total expectation theorem. The total probability and the total expectation theorem. Alright, what we will do in this video, we are going to look at one more problem, and this problem will be, you will see the usefulness of the total probability and the total expectation theorem, and we will be exploring little bit one more concept, that is the mixed random variable or the mixed distribution. So let's look at this problem. So we are going to understand this concept through this problem, and you will also see that how we are using the total probability or the total expectation theorem. Alright, first of all let's understand this problem. So suppose you have 1 rupees and now you have two choices. You either gamble or you don't, and you make this decision with equal probabilities, that is 50% or half chance for each. Now let's define this random variable x, which represents the amount of money you will have after this decision. If you do not gamble, then nothing changes, you keep your ₹1. So in this case random variable x will take the value that is equals to 1. But if you do gamble, then things get interesting. You either win or lose money, but the amount that you win is uniformly distributed between 0 and 2. So you gamble. If you gamble, then this random variable will be taking the value between these two, and it will be uniformly distributed between this range, right? So what is overall question? Overall question is that you are going to gamble, and you will gamble or not, that have the 50% chance, and you have 1 rupees already. So if you don't gamble, you will have the 1 rupees to yourself, right? But if you gamble, then maybe you will lose or win, whatever. So after gambling you will be having the money that will be uniformly distributed between 0 and 2, right? So this random variable x that we have defined for this particular experiment, right, will take the value that is equal to 1 with the probability half, right? And when this is the case, when you do not gamble, right, then you will have your money. And if you do gamble with the probability half, then you will have the money, either, I don't know, you will lose or win, but this information is given that you will have the money irrespective of whatever, that will be uniformly distributed between the value or the rupees 0 and 2, right? So this u is the notation for the uniform distribution, right? Now let me ask you the very first question: is this random variable, that is x, a discrete random variable? No, it will be not a discrete random variable. Why? Because x can take the value from 0 to 2, any value. So it is taking the value that is continuous in nature. So the answer to this question is no. Let me ask the next question: is this random variable a continuous random variable? No. Why? Because this random variable can take the value that is exactly x is equals to 1 with the probability half. And we have already seen that in case of the continuous random variable, taking the value that is exact will have the probability 0, right? But in this case, random variable x takes the exact value 1 with the probability half. So this random variable will not be also a continuous random variable. So the answer to this question is no. So what kind of this random variable is? This is what we call the mixed random variable. Now let me ask you one more question. What kind of distribution this random variable will have? Will it have the probability mass function, or will it have the probability density function? So this random variable x is neither discrete nor continuous, so we cannot define the PMF or the probability density function for this random variable x, right? So in case of the mixed random variable, the density function or the mass function will not be well defined, right? But what tool we have? The generic tool that we have is the cumulative distribution function. Irrespective of what kind of the random variable we are talking about, whether it's a continuous or the discrete, the cumulative distribution function will always be well defined, right? So if we have to write the cumulative distribution function in this case, then how we can write that we are going to see. And it is very much clear that for this kind of random variable we cannot have the PMF or PDF. Before we proceed for the CDF, writing the CDF, so if you look at this problem, we have two scenarios. The first scenario, you do not gamble, and the second scenario, you do the gamble, right? And each scenarios have the probability 1/2. So can we say that the first scenario, let's call it as A1 scenario, and that probability is half, and the second scenario that you do the gamble, let's represent this as A2 scenario, and it has the probability half, right? Using the total probability theorem, we can find this probability that random variable x takes the value less than little x, and this is nothing but the cumulative distribution function. So we have two scenarios, right? So maybe the probability that random variable takes the value less than equals to little x under the scenario A1, and we also need to weight this probability with the weight of the corresponding scenario, or maybe we have this another scenario where random variable x takes the value less than equals to little x under this scenario A2, and we need to also weight this conditional probability with the corresponding probability of the scenario. This is what the total probability theorem, right? And if we have to write this, we can write in terms of the CDF notation as well, right? So these all will be the conditional CDF. So we will have here the CDF of this random variable x given the scenario A1. Here we will have the CDF of this random variable x given the scenario A2. So we have this probability that is half, right? And the CDF plus the second scenario have the also probability that is half. So we have the conditional CDF of each scenario. So if you gamble, then what will be the CDF in that case? So the probabilities are uniformly distributed between 0 and 2. So the CDF will be 0 for the value that is negative, and it will increase linearly with the slope half till the 2, and then afterwards it will be 1. So this is the CDF of this random variable x under the scenario A1, right? I hope you do not, or you know that how I have drawn this, right? Because this when if you are gambling, then this random variable x is uniformly distributed between 0 and 2, right? And if you want to have the CDF of this, then this is what you will get. You will be integrating, right? And if you integrate this constant, then you will have this linear function, right? And what will be the conditional CDF under the scenario? So this is under the scenario A2, or whatever you would like to say, because both the scenario have the same probability. Let's write A2. What will be the conditional CDF under the scenario A1? Right, so it will have the 0 probabilities, and it will have the jump at x is equals to 1, and the jump will be total of 1, right? Because in this case we have the discrete, right? And random variable x takes the value that is x is equals to 1, right? So the total probability we will have at x is equals to 1, the total probability will be 1, right? So this is the conditional CDF under the scenario, under the first scenario. And if we have to draw the PDF of this random variable x, right, then how it will look like? So it will have the 0 probabilities for the negative values of x, and it will grow, or it will have a linear function with the slope half till 1, and at this 1, so how we are writing? We are writing using this, right? So it will, the slope will be not half but 1/4, because we have this term also, that is 1 divided by 2, right? So till 1 we have no contribution of this term, right? Till 1 we have the contribution of only this term, so half, right? And we already have this one till 1 with the straight line with the half slope, so this half will get multiplied, and it will have the slope of 1 divided by 4 till 1, and here at 1 we will have this contribution as well, and so at 1 we will have the jump of 1 divided by 2, right? We have the total jump here, but this, due to this factor, we will have the jump of 1 divided by 2, and again from here till 2 we will have the straight line with the slope 1 divided by 4. Till 2, right? And after 2 we have this term that is 1, and we have also this term that is 1. So after half, sorry, it will be 1. After 2 the contribution of this term will be half, and this will be half, right? Because after 2 this is 1, so this will be 1. Overall this will be half, and this will be also 1 after 2, so this will be half. So half plus half, that is 1, right? So anyone, if you have been asked that what will be the probability or what will be the cumulative distribution function at x is equals to 2, what will be your answer? Or x is equals to 1, let me know in the comment section, right? The question is, what's the cumulative distribution function value at x is equals to 1? Alright, we can ask one more question here, that what will be the expected value of this random variable x? Again, you can make use of the total expectation theorem, right? So let me know what's the answer of the expected value of this random variable x. That is all in this video. If you have any question, let me know in the comment section, or you can ask in the group, as well as you can create the doubt on our website. Thank you so much. In next video we will be starting with the joint probability density function, and we will look almost everything whatever we have looked in case of the joint probability mass function. Thank you so much.